Good morning. I am Engineer Kazim Seidu. I'll be your facilitator today for the training on Prota Structure. I'm going to be as practical, as simple as possible. I wouldn't be going through any theory because we've done a lot on that, and I believe by now you have learned. Like I rightly said in the Telegram group, that learning a software will not really make you a great engineer. But understanding the basics, understanding the fundamentals of all we have been learning for the past few days will make you a sound engineer, because the software will not run itself. You as an engineer will use your experience, your technical know-how, your understanding to tell the software what to do, because it is what you give the software that it would use to give you an output. If you give it inputs that doesn't make sense, it's going to produce an output that doesn't make sense. So you have to understand your code, your factor of safety, the requirements for every structural element in order to make good decision when you're using Prota Structure or any other computer-aided engineering software, as the case may be. So today, let's not talk much. I already gave some explanation in Telegram group. I've introduced you to the Prota Structure environment, the interface, and some things about creating axes, which is one of the first things to start your modeling in Prota Structure. So today we'll be modeling some little element, just some introduction into how you create your elements, your column, your beams, and the overview of the whole Prota Structure interface. So the first thing we'll do now is launch our Prota Structure. I believe everyone has a Prota Structure 2018. We'll be using Prota Structure 2018 for the purpose of this training. So I will go ahead to launch my Prota Structure now. Now our Prota Structure is launched. The first thing you notice is the first dialog box that comes out is your project window. Let's say the project menu, where you either select an existing project or you create a new project. If it's an existing project, you'd see the details of the project here. When you click on the project name, it tells you some of the project properties or some kind of snapshots of what it's in that project. But for the purpose of this training, we're creating a new file entirely, a new project entirely, and I would want my project files to be located in a particular folder which I created for the purpose of this training on the desktop. So I'll come here to select where I want my project folder to be. I want to select my project folder where I want my project files to be domiciled. So I click here, I go to the desktop. I created a folder which is Prota Training. I'll select the folder. Now I'm going to create a new project by selecting on the new project icon. Here you give your project a name. The acceptable characters from capital A to capital Z, from small letter A to small letter Z. Numbers are allowed, underscore and hyphen. The only character which is not allowed, I believe, is space. You cannot put space. You can't put space between a project name. So you have to know that. So for the purpose of this training, we are going to name our project lecture 01. This is our first lecture. So after typing your project name, select OK. And now the next window is where you have all the design codes. You have several design codes here, from Euro code to BS standard, and you have some other Malaysia code where they use Euro code 2, Euro code 8. And for the purpose of our own training here, we will be using the UK code, which is BS standard, BS 8110, which I believe everyone has a copy. We already sent out links to download that. If you've not done that, you can do it as soon as possible in order to follow along. So we'll select your code, the standard you wish to use in this project, and then import. Now we are in our Prota structure. I believe you're familiar with this already from the little explanation we did in the Telegram group. Now I'll be creating axes. We have three methods of creating the axis, which I mentioned earlier in the Telegram group, using the axis toolbar, using your orthogonal axis generator, and using an external reference drawing. Well, firstly, let me start with the axis toolbar. Here is our axis icon. This is the simplest form of creating the axis. It's like a freehand tool to create your axis. So what do? Let's select it. Now you have your axis property here. In the earlier explanation, in the notes I gave on the Telegram group, I mentioned something about the direction. You have two directions, which is the direction 1 and direction 2. Now first, the direction 1, as I mentioned, are laid out horizontally and are labeled A, B, C. So, but for your direction 2, they are laid out vertically and are labeled 1, 2, 3. So that is the normal convention in Prota structure. So now select when you select your axis icon, this comes up. This tells you, okay, the first axis will be labeled A. So what do? You're telling the software you want to draw an axis which is probably on horizontal. So you select a point where you want your axis to start. Let's select here. What you just do is just draw. Just draw. So there's nothing else. Just draw, select. You can pull it as far as possible. One thing that I described in the earlier note is you can also tell it the length of the axis by doing what? By toggling this value. By toggling, like press F2. When you press F2, it locks in the measurement. So here is asking you, define me, tell me the measurement, the length of it. So let's give this, let's say it's 20 meters, so that will be 20,000 mm. Let's press OK. So it's now asking us where the final point should be. You can see it is not increasing the length anymore. We already locked it to 20 meter length. So what do is just to tell it, okay, this is where it's ending. Now we have our axis. We have our first line of axis there. So that's created. So the next thing to do is to create more axes, as many as possible as you need. Let's say we want to create another one here. Yeah, okay, draw it, create another one. Let's create one more. So now we have 4 horizontal axes. Let's draw some vertical axes. You select your direction 2 in order to change the labeling. Let's create one here. Let's create one here. Here. Now can you see that? That's your axis. Now you've created axis, and this is ready to have elements being inserted. This is ready for you to use for your structural element. Okay, now the next approach is using our orthogonal axis generator, so which you have the icon here. So when you click it, you select a point, snap it to a grid insertion point on your model space. So let's select this point. So you are presented with the orthogonal axis generator properties window. So here you have the axis label for both directions. You have the direction 1 axis and the direction 2 axis, which I mentioned earlier. How they are laid out. The direction 1 axis are laid out horizontally, and they are labeled A, B, C, and so on. And the direction 2 axis are laid out vertically and are labeled 1, 2, 3, and so on. Now you have the axis spacing. This is like the spaces. This is the space, the distance from one axis line to another. So, for instance, you have here 5,000 asterisk 3. This is a shorthand of saying I want you to produce axis for me that would have 5,000 mm space in 3 places. That would give us 4 axis lines. From the first line, give me 5,000 mm. The second line, 5,000 mm. From the second line to the first, from the first line to second line, 5,000 mm. From the second line to the third line, give me 5,000 mm. Then from the third line to the fourth line, give me 5,000 mm spaces. So that gives us 5,000 in 3 places. This is like a shorthand. So this same shorthand is the same thing as writing 5,000 5,000, 5,000. So, and now you have the axis extension length. If you've done setting out before, there is a line, there is a point, like your building line, where it terminates. And you want to give some offset distance, some distance between your building line and your setting out your profile. You want to give some offset distance there. So that's what this kind of extension length actually represents in Prota structure. So you can just leave it at 2 meters, which is 2000 mm. So for our direction 2 axis also, we have this same 5003, but in order to have clear differences, so what we'll do is change it. Let's give it 3000 mm, 3 meter in 3 places. So leave the same axis extension length. So you press OK. So can you see now? This is for the horizontal, as for the direction 1 axis, we have this A, B, C, D, 4 lines with 5000 mm distance between them. In order to be sure, you can select your measure. Let's measure, let's see if this truly is 5000. So we have 5000 mm. So that is the second way of creating your axis. Now let's go over the third method, which is using an external reference drawing. So when you're using an external reference drawing, this simply means, for instance, an architect has already produced the drawing. You wouldn't want to go through the trouble of calculating where you want to put your axis, or you just want to be able to use the exact location of the structural element, thereby using the drawing in order to assist you to have to make a very good decision on that. So already I have a file, an external reference file. The external reference file, note, most times would be in DXF format. So what do? You come to your file, you come to your model file import. We are importing an external reference drawing. Let's do that. So the next thing, you have your reference drawing settings and window open. What you do is DXF load. Go to where you saved your file, your DXF file. I've saved it already in our folder, saved it by the name Aki. So what you do is select it and open. It will start importing depending on the size of the file and the speed of your computer. So it's importing it, so you have to give it some time to finish that. After importation, it would show us the other window where it asks you for more information about the drawing, the units the drawing is in, and it will ask you if you wanted to display some text that comes with the drawing. So let's just wait a bit. Now we have it. So what do? You select the units. In our own case, it's mm. Select mm, and I think we like it the way it is. So let's press OK. The next thing for you to do is just close this dialog box, and you have your external reference drawing. This is my external reference drawing, which I have inserted. You can see it's some kind of blurred out. It's not that obvious. That is because it is being displayed as a ghost axis layer. So as it is now, what do you do with this? What you do with this is just pick your axis icon and snap to wherever you want to put your axis. Just like you created the axis the first time using the axis toolbar. Here you have the axis property. Which axis do you want to insert at the moment? You want to insert our direction 1 axis, or you want to insert your direction 2. You select the applicable one. So this is to tell you that you must understand what you are doing exactly in order to create what you actually expected, or else you would be creating the wrong thing. So let's select the direction 1 axis and create an axis just by snapping to particular point. So we have that created. I want to put another axis here also. Put another axis here too. So can you see that? So now let's say I want to create another axis here too. Let's say I want to put some vertical axis. I select the direction 2. So I want to put one here also. Now you've created some axes. It's probably not obvious, and you don't want this drawing appearing there anymore. So let's close our axis too, but you don't want it appearing because you don't need it. All you need is your axis. So what you do is go back to your model file import, your external reference drawing, and just uncheck this. Close it, and you have it gone. And you have your axis here. So then you can start your work. So that's it. How to create your axis. Now you know how to create your axis in 3 different ways. So this is actually just the beginning of the work. Yeah, welcome back. Now we are going into the modeling part of our training. But before we model the sample structure I would want us to model today, I just want us to go over some few things, which are the settings, some of the settings that you would probably want to check to make sure that they are in the right place before you model or go ahead with your structural detailing and analysis. Now, the first one is the unit and format settings, which is under settings. Settings, and you go to unit and format settings. Here in this particular table, you probably won't be changing anything because most of the units there are already in the unit format we use in Nigeria here, and they are being carried from the code, the British code that we use, the British standard that we're currently using, which is BS 8110. Now you have your first inclinating, which is exactly what you want, among other settings here, including your mass, your stress, moment, unit weight, inclinating per meter cube. So this section, every time, 99% of the time, you want to leave it as it is. So press OK and get back to our modeling. The second one is the member and steel bar label templates. So you have the rebar labels. Here is how you want it to label your rebars, your reinforcement bars and detailing. So you're ready when as you're choosing the format, you have the sample here. So depending on how you want your rebar label to be displayed. Meanwhile, there is a standard for it, and you follow the normal standard. So you don't just detail just because you like it that way, but you follow a specific standard. Now let's go back to our modeling space. Now having checked that now, another thing is materials. For every building, every project, you have specific materials, and you want particular quality of materials. You already gone through that in the manual design analysis, which we had in the Telegram group. So I'm just going to show you how that is being provided for here in Prota Structure. And it's not like Prota Structure will just give you the best material. You have to tell it the material to use. That's why I said, if you don't understand what you're doing, if you don't know what to give the software, then you would be producing a very wrong structural drawing. So you must know what you want to use. You must know the value for a particular parameter in order to give the software the needed input. Now let's go. For you to edit your building materials, you go to analysis. Under your analysis, you go to building analysis. When it loads, now you have your building analysis window up. Here we have the parameters, we are loading combination, wind and story loads. We'll get to that in subsequent illustration. Now here you have your edit materials. Currently, these are the values of your materials currently. In a case where you are okay with these materials, you may not go ahead with edit materials. Probably you are working from an existing project which you already have your settings done. You probably don't want to edit materials. But now this is our own first project. We probably want to see everything is in place, so we want to edit material to check. Currently it's using a grade 25 concrete for columns and walls and beams up to the foundation. Then the steel is currently using is grade 410, which, if you remember, during your manual design analysis, you are being advised then when you are designing, you use 410. This is a very, very important thing to take note of. Use 410 when you are designing. Now, edit materials is what we do. So let's click on edit materials. Here you have your default materials and foundation floor. So for our default materials, for our concrete columns, you have the concrete here, the concrete property here, you have the steel property and the rebar diameter. Now let's check our concrete column. Already we have the C25. So if you want to check change your concrete strength that you want to use for your design, here you have the ability to change it. So when you see check, it's on C2025, which is you can see this is the strength, the characteristic compressive strength of the concrete, which is 25 Newton per mm square. So and which is what we want to use. Now let's press OK. So that means we are okay with all these definition here, the concrete strength. Grade 410 is what we want for our reinforcement. There are other grades. You have the grade 250, which is the mild steel, as you rightly noticed during your manual design analysis. You have the grade 460, you have grade 500, but like I rightly said a few minutes ago, use 410 when you are designing. So let's select our 410 and press OK. So we're not doing much in editing the material. Now let's model a simple structure of column, beam, and slab. Now to model your column, already know where the icon is. This is a column. So you click on column. When you click on column, you have the column properties window comes up. So now here, this is where you specify your column. So let's say we want to model our column of 225 by 225. Enter those values, then you just come to where you want your model to be located. Press it. So here I've made the views into two. I've tried it vertically to see what we are modeling in 3D as we're modeling. So now, right, let's create a column and let's create a one circular column. Instead of having 225 by 225 to model a circular column, you can delete it and just enter 0. This will give you a circular column. There is another way to model a circular column and not just this way. Now we have 4 columns. You can see we have 225. This is a circular column and these are the other square columns. So now, having done this, you want to insert your beam. So we'll come here, select your beam. What's the size of the beam? So we have a beam of 225 by 225. How should it be inserted? We want it to be central. So now, what do? Click on your column. So this is just a simple way of modeling column, beam. There are a number of ways, there are a number of type of beams you want to model as you go ahead in your practice. There are columns, there are slants, there are curved beams. You have a beam that will probably be slant at an angle. So there are ways to do that in Prota Structure, which we are going to look at in our next training. So having done this, we can easily say, okay, we want to insert a slab in this area. The slab is supported by the beam. So you just come, select kind of slab. Let's say we give a slab of 200 thickness. The concrete cover is 25. If you like, you change it to 20. So to insert a slab is very easy. Just click in the middle. But before we insert it, we want to specify some things. It has a separate. Immediately you are inserting immediately you're entering this figure. If I change this to 150, it's already compute the self load 3.6 for the kilonewton per meter cube of the load of the self weight. That is self weight of the slab. If I enter 200, then it computes the self weight of the slab. So other values, other loads you might want to enter would be if there are some predefined values there, like flat roof. Like what is the slab going to be used for? A flat roof, a room, a terrace, or a lowered slab. So let's say flat roof. If it's a flat roof, it has a dead load of 1 kilonewton per meter square. we are in post load. If you have a calculated in post load, which is your live load, all you have to do is just enter. Let's say you have a calculated in 1.5. But if you don't have, you can. If you don't have already, and you want to use some of the common in post load, just right click into this box. You have some lists of common impost load. Common, like for the general domestic use, the impost load is 1.5. You have residential communal areas 1.5. If the slab is going to be in a bedroom and dormitories 1.5, bedrooms in hotels and motels 2.0, hospital walls 2.0, toilet areas 2.0. You have the communal kitchens 3. You have the balconies for hotels and motels, which is 4.0, because these are places that experience high traffic. So, and so on and so forth. You have the foundries to 20.0. That can be as big as that. So if you want to select one of these commonly used areas to get your live load, you can just let's just select one, then just select it, and just like that, your slab is inserted. Just like so, you have your slab. So as simple as that, you model. Now, let us now say you are working on multi-story, on a multi-story building. That means you want to generate this up and up. Now, let me show us another functionality. Let us say, while you are working, your client says, oh, I've introduced another part, another building. I want you to please extend or make some alteration. Let's say we want to have another building here, which means we want to have another slab or a set of columns and beams again. So there is something we call offset axis. Instead of creating a new axis, you can actually offset an existing axis. You can also draw a new axis where you want it. But since you have an existing axis and you want to specify a distance from one axis to the other, just right click, select that axis, right click, select offset. So as you're moving your mouse, you're seeing it. If you come to this side, it's positive values on the x coordinate. If you come to this side, it's negative value on the x coordinate. So in order to explain, let's say I want this to be 4 meters away from this axis. So what I will do is just press F2. It locks in the data, the measurement. So I can just press 4 meters, which is 4,000 mm. Enter. Then you have that. I have that axis there, right there. So now, having that axis there now, so I can also offset one of these horizontal axis. So before I offset it, I notice it's short, which means I want to extend it to intersect with this new axis. So what I do, I just press stretch axis. Then I can just come, select the axis, stretch it to this level, and stretch this also. So now it means here now I can insert column, slab, and beam. So let's just insert some columns there. Now let's say there is no slab here. Let's say there is no slab here, so you can have a structure like this also. So these are just a few ways of modeling. Let's now say we want to translate this to another story. We have another story here, which are empty. Yeah, empty, nothing. So that's when generate story comes in handy. So just come to your story and click on generate. If you click on generate, it will come up with only the populated stories can be defined as source for generation, which means you have to select a particular story that has elements before you can generate story. Let's generate from our story 1. Let's generate it to story 2, story 3, story 4, story 5. It will down here you can specify the members you want to carry up to those stories you're generating. If I don't want the slabs to be taken along, then I remove the slabs. If I don't want the beams to be taken along, I remove the beams. Well, in our case, I want it to carry everything along. So let's select OK. And there we have it. Just by generating story, you have your structures coming into life the way you define it. You can see it is a circular column from the first floor to the last floor. Now this is where I'll be stopping now. For the next part of the video series, which will be a part of our advanced class, we are not going to be doing something simple as this. We are going to be designing, detailing a full project, a full residential building. That's what we're going to be doing, which means our work is not going to be limited to Prota Structure, but also Prota Details. When I'm talking about Prota Details is another software which is part of the Prota Structure suite. How does it work? When we are done working here in Prota Structure, you want to produce your structural detailing. So Prota Structure has the Prota Details software as part of the suite. All you just do is click on load Prota Details. It opens, it helps you generate all your details in particular. So we will be doing that in our advanced training class by God's grace. So thank you very much. Like I said, I will still say it again. Using the software is to help you to make your work fast, to help you with those repetitive process that you probably be wasting a lot of time on using manual design. But in order to get the best out of your Prota structure, you must be very good with your manual design. You must understand all the basics, all the parameters, everything that the code specifies. You must understand, and you must understand them. There are a lot of sections that I've not shown you here right now that I hope to show you in the advanced class if you sign up for it. So thank you very much, and thank you. I remain my humble self, Engineer Saidu Kazim. Thank you very much.